Welcome to Secret Spaces, everybody. Thanks for coming. Secret Spaces is a weekly Twitter space featuring Secret Network news and contributors and events from around the ecosystem. This week we're talking about Secret VRF, which, if you haven't heard about it, it's a random number generation service which was included in the latest Secret Network upgrade just a couple of weeks ago. And it's available to either developers building applications on Secret, or if you're building an application on another IBC connected chain, you can also make use of it by connecting to Secret Network and pulling those random numbers across IBC and providing them to your application on another chain like Juno or Osmosis or something like that. So very cool service. And before we dive into that, let's just go ahead and introduce our speakers. We have Lior from Secret Labs and Sean from Secret Agency. Lior, you want to introduce yourself?
Sure. So, hi everyone. My name is Lior Bondarevsky. I'm 28 years old. I've been working in the past 8 years in the cyber industry, and then I've joined more than a year ago. I've joined Secret Labs as a developer in the Secret Network.
Awesome. Thanks for being here.
Hey everybody, my name is Sean Rad. I do DevRel for Secret Network. I started my Web3 journey in Ethereum, doing a hackathon last summer, ETH New York, and then did another one called HackFS, and then found my way into the Cosmos and started learning Rust so that I could start building in the Cosmos, and I kept just finding my way to Secret. And so now I've been here since, I think I've been building on Secret since about August. I built a decentralized business card application on Secret, which kind of just brought me into the Secret community. And now I'm doing dev relations for Secret, and I lead the weekly developer call on Mondays at 12 p.m. Eastern time. So if anyone's listening who's a developer or interested in developing on Secret, definitely check that out. But I'm super excited to be here and to speak with everyone who's listening.
Awesome. Thanks, man. Well, before we really dive into Secret VRF and how it works and what it is, I figured first we should start off with why randomness is needed in the first place. And for people who are not developers, it may not be completely obvious why you need randomness, but there's actually a whole lot of use cases that require randomness in order for you to be able to build an application. So maybe, Lior, do you want to start off with that? I'm also happy to provide some examples as well, but with you being a developer, I would like to hear your perspective, especially on what requires randomness to work.
Yeah, sure. So I think that now when I looking in the past 10 years of development, I can't imagine not using random at all. Like even in games which are trivial, you use random for every little thing, like generating the map or choosing the skin of the account. Everything uses random. So games is a good example. Maybe another example is the whole world of gambling. Imagine having a poker game without the ability to shuffle randomly the deck. And the other examples are, of course, things with that are handling money, right? An easy example when handling money is by giving a reward to someone that is random and based on, a range of numbers. And the other things are, adding some noise to the transaction without the ability that others can see what the exact amount that you sent. And I can imagine a lot of things that are using random day to day.
Yeah, when it comes to gaming, there are so many things that really need to be randomized in order to make the game both interesting and unpredictable so that the game is actually fair to players. So like you said, the environments, like maybe pieces on a board, if it's like a board game, or if it's more of a 3D game, generating the environment itself, character attributes, item attributes, randomized events, potentially loot drops or matchmaking to make sure that you get matched up with completely randomized people. Pretty much everything really that goes into a game needs to have some form of randomness involved. So that's a huge one. And then, of course, gambling applications, lotteries, raffles, those things have to be unpredictable in order for the players not to have an edge. If you can predict the result, then obviously you can guarantee or at least increase your chances of winning. So those things have to be unpredictable. And then there are other use cases that are probably not as obvious, but can also be interesting, such as in DAOs. Maybe if you have a DAO and you wanted to randomize like a task selection, if you have something up for vote and you have to select certain members that will be involved, you might want to randomize that process. Or if you have some kind of vote that results in a tie, maybe you'd want to do like a tiebreaker, and you might want to guarantee that that's truly randomized. And even when it comes to NFTs, like if you're minting NFTs, you want to make sure that the minting order is randomized so that someone couldn't come along and try to grab the most valuable ones because they know which one's going to be minted next. So a lot of different things require randomness. But Sean, before I continue on, did you want to add anything to that?
No, I guess I think it's interesting to explore why it's difficult to achieve randomness on blockchains, and I guess
Right,
the
right.
solution that Secret has found and implemented.
That's what I was going to go into next, actually. So we've covered why randomness is needed, but why is randomness so hard to achieve on a blockchain, which is something else that might not be obvious at first. Do you guys want to go into that?
I can start maybe shedding some light on the dev perspective. So when you imagine blockchain, we all imagine a deterministic way of computing the same stuff on several computers. But when you imagine random, it's a non-deterministic number, right? You can't know beforehand what will be the number. So this is the main difficulty. Like, you need to make all of those nodes to calculate the same random number. This is the first difficulty, but it's the main one. And then when you have this achieved, you need to keep it secret. So what it basically means that in order to create a random number, you need to have a seed, which is basically a random number, but it's smaller than the actual random number. And with this seed, you actually generate all of these random numbers. So all of the nodes should have the same seed in the same status. So having this seed means that if you know what the seed is, you can actually know what will be the next random number without actually calculating it, right? So if I share with you, for example, the seed, so you can run it on your own computer and then understand what will be the next, 10 random numbers. And this is the main thing that we can achieve in Secret Network. Having the state encrypted, having the state private, lets us the opportunity to keep the seed private, which is very important in this case.
Don, you want to add anything to that?
A blockchain is just, when you say a node, it's just all these different computers that have they're sharing the same information for what this random number is. And so the first problem that you're tackling is just making sure that all the computers that are saving the state, the history of the blockchain, all have the same random number and also the same seed. And by seed, we mean the thing that is what generates the randomness for the random number. And then from there, figuring out how to keep that secure. And so that's like what is so unique to Secret, is that not only are we able to share this seed amongst all these computers to have the same state synchronized across the network, but also we're able to leverage the SGX technology on Secret to keep that number secure until we want it to be revealed.
And I would also say the transparency of other blockchains, it makes that difficult to keep that secret, because if you can see the formula that's being used to come up with this random number, there are some tricks that developers can use to kind of make things pseudo-random. They can pull from different sources and try to make it complicated so that it's at least hard to predict. But if there's any possibility of a user seeing that formula and seeing the sources of data that it's pulling from, there's often ways that they can predict the outcome of what that random number is going to be, which is the problem. So you have to make sure that it's unpredictable. So Secret VRF achieves that. So let's go ahead and move into what is Secret VRF. Lior, you want to start us with that?
Yeah, sure. So VRF is basically means the verifiable random function, which shouldn't tell like straightforward what it means, but When looking at random, we need to be sure that this random was generated by someone we can trust, right? We didn't discuss the main question: why do we need on-chain random, right? We can just have an oracle and we can get the random from the oracle. So the real reason that we need on-chain random is that we want to trust this random. This random might be the main key to win the game, and winning the game might mean having all of our money, right? So in order to achieve a random that we can trust, we want it to be on chain. But having a random on chain is not enough. We want it to be verifiable. We want some sort of cryptographic mechanism that can ensure for 100% that this random was generated on chain and by a trusted node or by a trusted, I don't know, provider. And this is what it's all about. Like, we want it to be verified and trusted.
And Secret VRF achieves that through the use of trusted enclaves, right?
Right. So if you want, we can dive into the main things of the algorithm of how do we achieve VRF. It is very interesting. We can do it like high level if you want.
Yeah, let's do that. I'd like to do that. We'll go high level at first. I think that would be good.
Yeah, sure. So what we basically do is having the proposer, which is the one who proposing the block, obviously, generating a random number inside of the enclave. So with all of the perspective of secret network, we have the enclave that is a trusted zone of ours that can be verified and cannot be manipulated. And there we generate a random number. Like when this random number is generated and of course encrypted and cannot be manipulated from outside, all of the other validators are signing this block with the random number. So what we basically have is a one node who generated the random number, or one validator to be exact, who is generating the random number in a trusted zone. And then all of the other validators can verify that the random number was generated in the trusted zone. And then they sign the transaction, sign the block. And once we have this, we can actually achieve all we need, because then when we can receive the random number, we can verify it, right? We have it encrypted with our own key that is kept as part of the trusted execution service. And then we can just decrypt it, see that the value seems to be correct, and then use the value as a random seed. So that's what is all about. We have a trusted zone who generates numbers, all of the validators signing them, and then, of course, validating it again when using it.
So how is like the node that generates the number chosen?
It's the proposer of the block.
The block proposer.
Yeah.
And yeah, and so, and for clarity, this is all just happening as part of Tendermint.
Yeah, correct. So we had to change some of the things in Tendermint in order to use the trusted execution environment and generate the numbers. That's correct.
And then when the proposer node proposes the random number, the other nodes, the first step is they're just verifying that the random number was generated within SGX, within the secure environment, right? They're not actually verifying the random number itself, just the fact that it was generated in the secure environment.
Yeah, that's correct. You actually cannot verify a random number. It's just a blob of binary data, but the actual thing is to verify that this is what's generated by an SGX, of course.
Got it. And how do you like counteract that it's not something else that was generated within SGX? If you can't actually see what it is, if the other nodes don't have access to the information, how do they know that it's like the thing that the proposer says it is?
Yeah, so it's a part of a protocol. It depends on where exactly in the packet. You can call it a packet, right? So it depends on where exactly in the packet or in the block, in our case, the data is written, and they all expect the data to be written in a specific place where they can be sure that the data there is the random number that was generated by the proposer.
Got it. Cool.
So let's talk about who can use it then. One of the most interesting things about this is that it's not only accessible by secret dApps, but can also be used over IBC. So there's a couple different things to think about, whether you're building it on Secret or on another chain, because if you're building it on Secret, you can actually keep the random number private if you would like to. Depending on the application you're building, maybe the design would call for that, for you to never reveal the random number to the user at all. That can be done if you're building the application on Secret. If you're building it on an IBC chain and pulling this random number over IBC, in that situation, the number does have to be revealed to the users because the data is going over to a public chain. But that's not always a bad thing. A lot of times, it's not necessarily that you need to keep it private the entire time. You just need to make sure that it's unpredictable up until the point that it's revealed. Do you guys want to talk about how? I guess first you can talk about how a secret contract is able to access this random number. How can it call it? And then after that, talk about how an application on another IBC connected chain would make use of it.
Yeah, sure. So I will assume that part of you know how a secret contract or a contract on CosmWasm looks like, but like if you imagine a function, an execute function, or an init function, you can actually see that all of these functions has an environment that they receive from the chain, which is basically a structure that contains a lot of things that are related to the block itself. One of the things that is written by us is actually the random number. So what this basically means is that you access the environment, and then you can just simply get the random number, which is generated for each block. So on every new block, you can get a new random number. What is more interesting than that, every contract receives a different random number. So the way we create random number is by having the proposed seed that was proposed by the proposer, and then we are adding to it we are concatenating the a unique identifier of the contract and then hashing all up. So what you basically get is a unique random number for your contract per block. So this is the aspect of a secret contract developer. If we look a scale upper and we will imagine a contract that is written in other Cosmos chains. So in this case, you will need to use IBC. So the main thing that I would note here is that you don't want to receive a random number that will be used as your seed, because if it is used as your seed, you will have the same problem of privacy. You will store it in your state, and then everyone can predict the next random numbers. So the way to do it, I think correctly, is by asking a random number whenever you need a random number, and letting Secret Network do the manipulation of storing the seed and having a new seed for every block, which is used on which is implemented, of course, on Secret Network. What I think is the best practice of IBC usage of random numbers.
So what is like the reason why you couldn't like let's say like have a vault of secret random numbers that only certain contracts have access to, like rather than the random number being generated each time with a new block? Like, could there be a way where there's like a finite amount of numbers that have already been generated, and then other contracts can query those random numbers if they have specific credentials?
Yeah, it can be developed by a contract developer for sure. Like, we generate a random number for every block. The actual logic of the contract can be done by the contract developer however he wants. He can create, generate thousands of random numbers as part of its instantiation, and then allow others to query with the permit and get these numbers. It's a thing that is relevant for those who want it, right? There are some people who want a random number that is provided by the blockchain or every block. It can be accessed. Like, the choice is done by the developer.
Right. Yeah. So you created an approach that's extremely flexible to give developers the maximum amount of control over how they write their contracts.
Yeah, that's correct.
So could someone that's developing an application on another IBC chain they could build a proxy contract on Secret that pulls from Secret VRF, uses that random number as just a seed, and then within that proxy contract, it could use that seed to generate like a whole, let's say, 100 different random numbers. I think that's what Sean was saying, that they could actually have like a database of random numbers ready to go. I'm not sure if that would be faster. Like if it had 100 random numbers in that proxy contract, would it be faster for the application on the other IBC chain to pull directly from that contract? Or does it not really save much time and you might as well just use it directly from Secret VRF every time? I'm not a
Somehow.
developer, so I don't know if that made sense. Let me know if you need me to clarify
Yeah,
what I'm trying to say.
yeah, it's okay. So, just to be exact, just to be clear, we have a contract, a proxy contract, that can provide random numbers, but it works like in our logic and in our way. And people who need a different way or different logic can for sure create one for themselves. But when talking about the performance, it really depends uh, on your needs, right? It depends on how many random numbers do you need, and in what I don't know in what I forgot the word, but you want it like once per block, or in what duration, right? Once per block or once per several blocks. So it really depends on your needs and your logic.
Yep, makes sense. So Secret developers can use it when they're building an application on Secret. IBC chain developers can use it when they're building applications on other IBC connected chains. And something else that we haven't mentioned yet is that Secret VRF may eventually, let's say, it's extremely likely that it will eventually also be accessible to EVM chains. Um, I believe, from what I understand, that it would just require something to be added to the next secret network mainnet upgrade, IBC hooks. Is that right, Leor? And then
Yeah,
you
that's
could
right.
potentially,
We're
and then you could
planning to
potentially use it over something.
Yeah, yeah,
Sorry.
that's correct. It's okay. Sorry, we're planning to implement something that is called the IBC hooks, which will basically give us the opportunity to provide random numbers to EVM chains with I don't know if all of you are familiar with, but it's called the Axelar GMP, which is a general message passing, which is a general name that means that EVM chains can access Cosmos chains with Axelar provided.
Yep, that's what I was going to say. The XLR GMP, that would be awesome. Been looking forward to Secret making use of that for a long time, and XLR GMP just went live for Cosmos chains. It's been a few weeks now, but pretty recently. So definitely excited to see that put to use.
Yeah, it's the future. We're very close to the future.
And this is just the first privacy as a service application that Secret Labs has built. There will also be others that will likely make use of XLR GMP too, which was going to be huge, I think. But more to come on that. Is there anything else that we didn't cover that you guys would like to discuss, Leo or Sean?
Two thoughts. One is just that for anyone who's a developer who's listening, Secret has documentation for all of this, which I linked in the chat below. So you can see there how to implement this. Like you just have to add the feature random in your cargo.toml file, and it shows an implementation with a coin flip example. And there's also a piece of the documentation that shows how one might do this via IBC. So definitely check that out if you're a developer who's interested in using this API. Leo, I'm just curious, like with your background, being someone who's extremely technical, and someone who's primed in like working with cryptography, when people ask you or just ask the question like why blockchain, you know, people who are non-believers who aren't already part of this ecosystem, what what is your response to that as somebody who's been working in this space for a while? And what is like you think is like unique about this space that you think makes it special, and why you're working in it?
Yeah, that's a great question. Actually, I had many thoughts about it before I joined Secret Labs, and I think that the main thing that is very important in blockchains, that like it's the future, is that decentralized. So, of course, all of the people will say it's very obvious, but one of the main concerns for me as a developer, as a person who had been in the cybersecurity industry, both in the army, in the Israeli army, and then in uh, in a company that developed the antivirus, it was really it amazed me that everything I decide to do as a developer is like is like a law, right? All I do is create some code that decides uh, what is correct and what is incorrect. And my code is the only decision, of course, my and my colleagues' code, but it's the only decision that makes it. If I have a mistake or something that I want to, I don't know, a backdoor that I wanted to add to the antivirus. So for me, it's very easy, right? When having a decentralized network where all of the nodes, all of the computers should have the same result for the same input, it's very hard to manipulate. For me, it's very easy to trust, right? Blockchains, like the main thing that blockchains handled until I don't know, a few years ago, it was money. Like people couldn't trust the government, and they couldn't trust the banks to to keep the bookkeeping correct, right? And when having a decentralized world, when where a lot of computers calculate it and store the same data and do the same magic, it amazed me. Like this is the main goal for me, and the main reason I joined Secret Labs.
That's awesome. Yeah, I know. I don't know if you've been following just like this really high level AI phishing that's been coming out recently with people receiving phone calls from people who sound like family, asking for bank information, and things like this. But I don't know. I wonder if like somehow a public ledger that is, where there's consensus, if that will come into play in terms of like combating really complex phishing attempts in the future, if blockchain will have a role.
Yeah, the complexity of attacking blockchains, I think it's higher than attacking a centralized service. Of course, phishing attacks are I don't know, they're very clever and they can ask you for the mnemonic and that's it. But having said that, I think that when I don't know, when you need to to attack all of those nodes and let them I don't know, have them compute something that is not deterministic or something that is not correct, it's harder. It's way harder.
Yes. So I'm just going off. I could just ask Lior questions all day because I think what he does is fascinating. I think something that a lot of people don't see who might be token holders but not developers is they just see the price of the token and then the fact that we're in a bear market. But working in DevRel, I get to really, I guess, see the cutting edge of what you guys are working on every day at Labs, um, and just see how exciting it is, and just see how much development is happening literally every day, and how you guys are at the precipice, kind of pushing us forwards and with privacy tech. So, is there anything you're working on right now, or like something on the horizon you're excited about with Secret that you just think like might be exciting to people who might not know what's going on behind the scenes?
So I think that the last upgrade and the things we talked about, which are VRF and all things that are upcoming next as part of the privacy as a service, and the communication with other chains is the uh, for me it's very exciting, right? I've joined Secret Labs when there were no usages of IBC, and like it was amazing that we have all of those things, but we knew there are applications that are running on other chains that cannot use that. So the communication between blockchains is amazing for me. Like I think I said previously, it's the future for sure. We are soon to be a multi blockchain in a multi blockchain world, and it's amazing.
Yes, awesome. Yeah, I don't even think we can fathom yet what this is going to do. We're going from this like kind of, it's almost like we're realizing the promise of the cosmos, that we're becoming truly interchained, and it's exciting.
Yeah, and we talked about GMPs, which like having it giving us the ability to communicate with EVMs. It's amazing. You guys need to imagine like how many opportunities there are when Cosmos can communicate with other chains, and EVM contracts can get random numbers from secret network contracts. It's amazing. It's like like a new world.
Yes, EVM, for anyone who's listening, that's the Ethereum virtual machine. So they were saying the Secret is going to be able to communicate with Ethereum shortly, and so is the rest of the Cosmos. So there's just going to be I don't know, a proliferation of technology probably possible with just, the more communication happening between blockchains, the better.
And not just Ethereum, but all EVM-based chains. So things like Avalanche and Arbitrum, Polygon, a lot of the major networks out there are EVM-based. So it's just a whole new world of possibilities. Well, we'll go ahead and start wrapping things up, I think. Leo and Sean, thanks for being here. Really appreciate your time. To everyone listening, thanks for being here as well. Make sure to come back next week. We will be here every Tuesday at 4 p.m. UTC. Anything else you guys want to say before we wrap things up, Sean and Leo?
Thanks so much for having me and for having us. It's always a pleasure. And everybody who's listened, check out the secret documentation that's linked below.
Yep.
And if you have any questions, just ping me on Twitter or Discord or Telegram, and I'll be sure to help you out.
Yeah, thank you so much for having us. It was amazing. It was nice to talk about the new things we developed, and for sure you can address me whenever and wherever you want, on Telegram, on Twitter, on Discord. I'm always available.
It looks like I just got a DM from Joe. While we wait on Joe, looks like we have another request from Fuzzy Pizza.
Hey, Patrick. Figured if we had a few more minutes, I would ask a quick question. Lior, if you had three applications or three contracts that could use VRF in a novel way, what would be three applications that you see would be really cool to be developed on Secret?
Yeah. So my personal perspective is going straight forward to the gambling side. It's very like I've been talking with all of my friends that are gambling on internet, and the main thing that is going on there is that no one there trusts the casino. No one there trusts the random number generator of the casino. They all think, and I think they're right. Yeah, they all think that the casino only tries to steal their money, and with this amazing thing of verified random number. And a random number that is generated by a chain that cannot be manipulated. I think gambling is like a magical thing that can be done with random numbers. Besides gambling, I think that deciding in DAOs, as Patrick said, all of the ties and the loot boxing and everything that is relevant to the DAOs. And I think, of course, gaming, right? I can imagine games that part of them is developed in a centralized way, and the other part that is the more interesting part is developed on chain, and then these interesting parts need random, of course. and also an amazing thing. So my first three in the same order is gambling, then DAOs and games.
Yeah, that's super cool. Gambling, being able to trust that the number random is actually random is super cool. How do you verify that the random number is actually random?
Yeah, so you can't verify the validity of the random and the strongness of the random number, but you can verify that the random number is created by the trusted environment. And when you can verify that the random number is created by the trusted environment, so we basically just need to trust that the code that is running in the trusted environment is the code that we published, right? And you can see the code and you can see how the random number is generated, and that's it, right? So we trust the trusted environment, and by trusting the environment, we trust the random number.
So you're saying so just going back, I just brainstormed a couple of other things. So if you're saying there may be a future where a lot of gambling projects that are across all networks, including Ethereum, other EVM compatible chains, Cosmos, etc. If they wanted to build a decentralized gambling casino, Secret would be one option for enabling all these use cases for every application that would want to use gambling.
Right, that's correct. Like imagine that it should be the main thing, but yeah, basically one of the things for sure.
Gotcha. And then currently, I've noticed also on Chainlink, a lot of people are using Chainlink for their VRFs. That's what an off-chain solution. So you would have to trust Chainlink for their random number. How do
Yeah, that's
I
correct.
guess so? Trusting an off-chain solution. I guess the main risk there is that the random number could be manipulated for certain scenarios.
Yeah, that's right. Like we need to imagine that even if they publish their code and we can see that this code is running there, they can always change the code, right? They can judge the server that you are using for retrieving these random numbers. They're the leads. They have the lead to change whatever they want whenever they want. So this is the whole risk of having an off chain random provider.
Gotcha. That's a lot of good ideas. Thank you.
So I did get a couple of questions from Joe. One of them was basically what Fuzzy Pizza just said. How do applications that currently make use of oracles like Chainlink VRF, how is that different? And the second one was, how do you guys see Secret VRF being used in DeFi applications? Which is something we didn't really cover, but there are some potential use cases for randomness in DeFi applications. Not sure if you guys want to just discuss those if you have any off the top of your head.
Nothing I can think of straightforward at the moment, but I'm sure there are use cases that DeFi's will need randoms for, and nothing at the moment. So
Yeah, most core DeFi functionality doesn't really require randomness, but one that I had read about was if you have a stable coin, sometimes if there's a market condition that is risking a depeg, sometimes they'll need to rebase the value of that token. And if they do that in a predictable way, it can open up the situation where people can arbitrage and take advantage of that upcoming known price difference. But if they incorporate some randomness into that rebasing strategy, then basically it can stabilize that process and make it so that nobody's able to exploit the price difference because they don't know what the exact calculation is going to be to rebase.
yeah, actually, it sounds very very correct. Like I can imagine others using randoms for these purposes. Actually, the main thing I thought about, and maybe nice to mention from the cybersecurity perspective, is that when I imagine cybersecurity, I imagine a war, right? There are people who are trying to attack systems for their own usages, and then there are people who are trying to protect those systems. And the main thing in a war is that you want to be you don't want to be predictable at all. Like if you can be unpredictable, I think it's a game changer. And I think that a random number and a random provider was used in cybersecurity in a lot of things. Like people cannot imagine how random a simple number that cannot be predictable is solving the whole game. Like it makes it unattackable or almost unattackable. It's very nice to think of a small number that changes everything.
And Joe also said that he would like to see some low-hanging fruit like a roulette game or a blackjack game built using Secret VRF.
Yep. Actually, one of the first things I've done in Secret Labs was, as part of my training, was a blackjack game, and then it's not on mainnet, unfortunately, but one of the things I wanted to do is to use VRF as the solution of the random generation there.
Yep. And a little alpha here. I think we may be seeing something involving a roulette game in the near future, so keep an eye out for that. But we're at the top of the hour now, so I'm going to go ahead and wrap things up. Thanks for being here, everybody, and we'll see you on the next edition of Secret Spaces. Have a good week.